is about measure of variation, or it is also called measure of spreadness or measure of dispersion. Now, first we define that what is a measure of variation or spreadness, scatteredness or dispersion. That how mean value is. We basically observe that what is the spread of different values from mean value. We have different measures like range, interquartile range, semi-interquartile range, and it is also called quartile deviation. Then we have mean deviation. We have other deviations as well, like its deviation from median or as well as from mode. Then we talk about variance standard deviation for population data, variance standard deviation for sample data. Then we have semi-variance and semi-standard deviation as well. Then if our data is differ by size and if we want to compare two or more than two set of data, then we use coefficient of variation. And then we have standard deviation for probability data, then weighted variance and weighted standard deviation as well, standard deviation for portfolio, and then downside standard deviation. Now I will explain all these measures one by one in detail. And in my next video, I will also explain all some of prominent measures with the help of data as well. Now the first one, that is range. Now range is basically it is the difference of maximum value and minimum value in the data. Then it is not a good measure for variation. Then we have interquartile range. For this, we should have a quartile. It is the difference between first and third quartile. But in this measure, we almost ignore 25% of the data. We have another measure that is called quartile deviation. If we divide this interquartile range by 2, we can get this measure divided by 2. Then we have mean deviation. For mean deviation, as we know that the mean the deviation from mean is always 0. So to calculate this measure, we take absolute value, and that is divided by n. Then we have variance and standard deviation for population data. Now I'm writing here for population variance, we denote it with the help of sigma square. And we have like this formula, summation x minus x bar square divided by n. And if we take its under root, it becomes standard deviation. Now we know that what is the formula for simple mean. The simple mean formula is x bar summation x by n. Now, if we observe here, we have summation and symbol, and here we is also summation and n symbol. So it is, we can define that variance is basically average of square deviation, because these are square deviation, we are taking average. So variance is also an average. And now we have a computational formula, because most of the time we will have to do calculation manually while appearing in the exam or in quizzes. For this purpose, uh, this formula can be used to calculate variance as well. This is called computational formula, summation x by n whole square. Now, if we take its under root, it is called standard deviation. So just take the under root of variance. Now for sample data, and definitely we have the formula for group data as well. So variance for group data is summation f x minus x bar square divided by summation f, and we have computational formula as well, and where x bar equal to, because it is group data, summation fx divided by summation f. Now for sample data, we denote variance like this one, summation, x minus x bar square. The numerator is same like in population that we have used the formula in for population data, but here it is divided by n minus 1. It accounts for degree of freedom. Now for computation formula, we have n summation x square minus summation x whole square divided by n minus n into n minus 1. Now, if we take the under root of this s square, we can get standard deviation for sample data. Now, semi-variance or semi-standard deviation, almost the same formula, but here the only difference is that we take first average, and then we take, for example, here I denote RT, and then we take deviation, square deviation, and where this RT is basically less than average value. This one. I am just highlighting this. RT, each value, that should be, we will take those value that is less than average value. And then it is divided by n. And when we take its under root, it becomes semi-standard deviation. And now it is very much similar to variance, but it only considers observation that are below the mean. Now the next measure is coefficient of variation. We basically, as I have already explained that if we compare the two set of data and more than two set of data, and data is differ by size, so simple standardization will not give you an accurate result. So we standardize, use coefficient of variation, and that is standard deviation divided by average value or mean, or sometimes it can be multiplied by 100. This formula for. Now we have other coefficient as well, like coefficient of quartile deviation and so on. Then standard deviation for probability data. For probability data, I will write the formula here. If our data is based on probability, then variance can be calculated like summation P into x minus summation px whole square. I will explain its calculation as well. And it is basically standard deviation formula, and without under root, it is basically variance formula. And for computational purpose, we use this one, summation px square minus summation px whole square. You will get the same answer, and we will learn that the second form is how easy to calculate. Then we have weighted variance or weighted standard deviation. Sometimes we have weighted data, and if we want to calculate weighted variance or weighted standard deviation, then we can use the formula. Just I will write it. It is basically first we write weights that multiplied by deviation. Here in deviation, we use weighted average. Like in simple deviation, we use only simple mean. Here we use simple, weighted mean. And then we take again its square, so that we can get square deviation. And that is multiplied by weights. And then we sum it. And then it is divided by, we have n minus 1, and that is multiplied by sum of weights. I will also explain it is basically weighted standard deviation. Standard deviation weights, if we take its under root, without under root, it is variance. Then we have the formula for standard deviation for portfolio. And for this purpose, I have uploaded a video that in portfolio analysis, you can get the calculation of this formula. Anyhow, we have the formula that is we have a number of formulas. Just you can use this formula as well. And if you open it, you will get this. For example, if in our portfolio we have 3 assets, and if in our portfolio we have say 10 assets, then we should have 100 different combinations. You can see that video and can learn calculation of that how we can calculate standard deviation for portfolio. Then for downside, we can use this measure that this is basically X, and then it is target return, or it may be you can use simple average of those returns, and then we can penalize those returns that are deviations are negative. Like if our this each value is less than average value or target return, it is not necessary that we will take average. We can take a benchmark like target return. We put one for this negative, otherwise zero. It basically include those deviations that are negative. I have also explained that how we can calculate this downside risk in my portfolio performance measure. So this is all about that. What are these measure of dispersion that are used to capture the effect of scatteredness in the data. In my next video, I will explain calculation of some of these measures. Thank you very much for watching this video.